Hey there, welcome to our brand new video. In this video, we'll be discussing the key benefits of CMDB. But before we dive into the topic, if you're new to our channel, please subscribe and leave a comment in the comment box below. And don't forget to hit the bell icon to stay updated on our latest videos. Now, let's get started. Think of CMDB like a big mansion with lots of rooms, configuration items or CI types or classes in it. Now we are talking about what is CMDB. CMDB is an acronym for Configuration Management Database, a data repository that holds configuration information of devices, or assets and their logical entities, relationships within the IT environment. The records are stored throughout the lifecycle and their relationships to each other. It acts as a data warehouse to hold, maintain, track, and manage information about a wide variety of IT services and/or digital services known as configuration items, CIs, typically including hardware, applications, software, storage, cloud components, servers, networks, buildings, people, suppliers, and documentation, along with the descriptive relationships among them and the operational usage of those assets. A CMDB is like a mansion. It's big, impressive, and contains many different rooms, popularly known as configuration items classes. But, unlike a mansion, it does not contain furniture or fancy decorations. It contains data that is used to manage IT infrastructure and track the changes over time. The CMDB is an invaluable tool for IT professionals, but many struggle to get the most out of it. In this blog post, we will explore how to best utilize your CMDB and why it should be considered the foundation of your IT estate. We will talk about how a well-built CMDB can simplify complex tasks and help you get the most out of your IT. Now about purpose of CMDB. The main purpose of a CMDB is to help organizations keep track of their IT assets, configurations and relationships so that they can be effectively managed and maintained, and can also be used for auditing purposes, or to help troubleshoot IT incidents, perform a change and root causes. A CMDB can be thought of as a mansion, containing all the information on an organization's IT infrastructure. Just like a real mansion, it needs to be properly designed and maintained in order to be effective. Otherwise, it can quickly become cluttered and difficult to navigate. If you're thinking of setting up a CMDB for your organization, make sure to check out our blog post on the 5 essential steps for designing an effective CMDB. Configuration items classes as big rooms in a CMDB. The configuration items classes are like the big rooms in this mansion. Each one is designed for a specific purpose, and each one contains specific information. They are actual tables in the CMDB. These table holds the group of configuration items, CIs, that share the attributes and are stored in their own table. Windows servers, Linux servers, application service, IP router are all configuration items classes. You can have parent and child configuration items classes too. The configuration items classes are the foundation of the CMDB. They provide the structure and organization that is necessary for effective management of all of the configuration data within the CMDB. Without the configuration items classes, the CMDB would be a chaotic mess. Here are common primary configuration items classes in most CMDBs, but not the exhaustive list. There are infrastructure, applications, services, data. Infrastructure. This class includes all of the physical infrastructure components that make up your IT environment, such as servers, networking gear, storage arrays, etc. Applications. This class includes all the software applications that are installed on your servers and other infrastructure components. Services. This class includes all the services that are running on your servers and other infrastructure components. These services could be web services, database services, email services, etc. Data. This class includes all the data files that are stored on your servers and other infrastructure components. This data could be application data files, system log files, database files, metadata snapshot, etc. For example, you can have Microsoft Dynamics as a business application, Microsoft Dynamics Production as an application service, Application Management as a technical service, Dynamics Administration as a technical service offering, Sales and Marketing as a business service, Dynamics CRM as a business service offering. Configuration item, CI, as a unit within CMDB. The configuration items, CI, is the fundamental structural unit in the CMDB. A CI represents a component of the infrastructure and contains information about that component, e.g. M365, SAP host, prod, etc. This information includes the configuration settings for the CI, as well as its relationship to other CIs. Think of CI-like family members living together in a room, i.e., CI class. The CMDB is organized into a series of layers, with each layer representing a different level of abstraction. The CI is located at the bottom layer, which is the most concrete and specific level. Above the configuration items are a series of progressively more abstract layers, including the application, service, and infrastructure layers. It makes sense to start by defining your attributes at the highest level, i.e. configuration items class level, so that attributes can be inherited or cascaded down to layers. The CI is linked to other CIs in the CMDB through relationships. These relationships can be either physical or logical. Physical relationships represent a real-world connection between two CIs, such as when one CI is contained within another, e.g., a server is contained within a rack. Logical relationships represent a logical connection between two CIs, such as when one CI depends on another, e.g., an application depends on a database. The CMDB provides a complete picture of the IT infrastructure by representing all of its components as CIs and their relationships to each other. This information can be used to understand how changes to one CI might impact other CIs, and to plan and implement changes to the infrastructure in a controlled and safe manner. Data structure in the CMDB. In a CMDB, data is organized into a structure that allows for easy retrieval and updating of information. This structure is known as a data model. The data model in a CMDB defines the relationships between different pieces of information, making it possible to store and retrieve data in a consistent and logical way. A common type of data model used in a CMDB is the relational model. In this model, data is organized into tables, with each table representing a different entity, such as a server or application. Each table has a primary key that uniquely identifies each row, and foreign keys that identify the relationships between different tables. Another type of data model that can be used in a CMDB is the object-oriented model or logical data model. In this model, data is organized into objects, with each object representing a different entity. Objects have attributes that describe their properties and methods that define their behavior. Relationships between objects are represented by links. Which type of data model you use for your CMDB will depend on your specific needs. However, both types of models have their advantages and disadvantages, so it is important to choose the one that best suits your needs. Relationships mapping in the CMDB. A configuration items does not exist on its own. A CI is always dependent or related to another CI. CMDB gives that end-to-end view on how CIs interact with each other. As the CMDB grows, it becomes increasingly important to map relationships between different pieces of information. This helps to understand how different systems and processes are interconnected and can identify potential areas of improvement. There are many ways to map relationships in a CMDB. A good data model will help. One popular method is to use a matrix diagram, which can be used to visualize the dependencies between different elements. Another common approach is to use a graph database, which can be used to identify patterns and trends in the data. Whichever approach is used, it is important to ensure that the relationships between different elements are well understood. This will help to make the CMDB more effective and easier to maintain and avoid duplication, staleness, and orphan CIs. Attributes and attribute levels in the CMDB. Attributes are the data elements that define a CI, like name, description, owner, location, business criticality, etc. A core group of attributes will be same across CIs. Although, they can be consistently maintained at different levels to support attribute inheritance, such as base level, configuration items class level, and individual CI level. There are three common different types of attributes in the CMDB: static, dynamic, and calculated. Static attributes are those that never change, such as an asset's serial number, name, etc. Dynamic attributes are those that can change over time, such as an asset's location, business criticality, etc. Calculated attributes are those that are derived or inherited from other attributes level, such as an asset's age. Attribute levels define how granular the data in the CMDB is. The four attribute levels can be basic, intermediate, advanced, and expert. Basic level data is typically captured during discovery and includes things like an asset's IP address and hostname. Intermediate level data is more detailed and includes things like an asset's operating system and service pack levels. Advanced level data is even more detailed and includes things like an asset's installed applications and patches. Expert-level data is the most detailed and includes things like an asset's configuration files and registry settings. Some attributes can be unique to a configuration items class, e.g. server model, or specific CI instance, e.g. server XY123 last audit date. Please like and click on the subscribe button. We really appreciate you and your feedback to improve our content.